In this lesson we do some work with right-angled triangles. Now firstly, finding a side. The first example, we need to find the value of m correct to 1 decimal place. Well, some old hags can't always hide their old age. Okay, so our trig results there, sokatoa, you may remember, but I'll remember as some old hags can't always hide their old age. And I'm very deliberate how we write it down. Okay, the O is over the H, the A is over the H, and the O is over the A for tan. So the first step with all of these is to identify the two sides in relation to the angle. So the angle there, 32 degrees, directly opposite that, funnily enough, is the opposite side. The 18 in this particular triangle is the hypotenuse. So we've got opposite and hypotenuse, we're going to use sine. So we write 32 degrees is the angle, we write the sine of 32, and that equals the opposite over the hypotenuse. So you can see there, that's why I wrote it as a fraction like that. Even we didn't put the fraction bar in, but certainly looks like a fraction, doesn't it? Opposite over hypotenuse. So in this case, m over 18, we'll just rewrite that because there's some cancelling to be done. We need to get the m by itself. At the moment it's being divided by 18, so let's multiply both sides by 18. On the right they will cancel. Terrific, we've got m by itself then. 18 times sine 32. Now we do that on the calculator, we get that m equals 9.5. We've rounded it off to 1 decimal place. Now I'm deliberately showing you each of these steps here, one step at a time. With practice you could probably skip at least one of these lines, but I will show you these lines in this lesson. The second example, find the value of m corrected 2 decimal places. Again, some old hags can't always hide their old age. Identify the two sides. Well, there's the 47 degrees. Directly opposite that is the opposite side there. And that m is next to it. Okay, another word for next to is adjacent. So we've got opposite and adjacent. So this time, tan. So we're using tan. The angle is 47, so we write tan of 47 degrees. And it equals the opposite over the adjacent. So in this case, 7 over m. Now just rewrite that again. Now there's m, this time it's on the bottom. Alright, so we need to multiply both sides by that m such that the fractions will disappear, so those m's will cancel there. So we've got m times tan 47 equals 7, and because m is multiplying by that tan 47 to get rid of it, let's divide through by tan 47. On the left hand side they will cancel, so we do have m by itself. And on the calculator, 7 divided by tan 47. Now I suggest you use the divide button rather than the fraction button. On some calculators the fraction button can be a little bit unpredictable in how it's going to react, so I'd press the divide button. In any case, 6.53 rounded to 2 decimal places. The third example, find the value of x correct to 1 decimal place. Well, some old hags can't always hide their old age. There it is. Identify the two sides. So there's our angle. The 15 is the hypotenuse, and x is right next to it. It's the adjacent side. So we have adjacent and hypotenuse, so we're going to use cos. So the angle is 38 degrees. We're using cos, so we write cos 38 equals the adjacent over the hypotenuse, so it'll be x on 15. So let's write that down. We're trying to find x. At the moment it's being divided by 15, so the opposite of that. Let's multiply both sides by 15. The reason being those 15s will cancel. So we have the x by itself. 15 times cos 38. We'll do that now on the calculator. We get 11.8 to 1 decimal place. Now we'll do some work on finding an angle. The first example, we need to find the value of theta correct to the nearest degree. Well, as before, some old hags can't always hide their old age. It's one of the good things about this. It's fairly standard, what we need to do. And we also need to identify the two sides. So there's our angle theta we're working with. That side there is the hypotenuse, and the 15 is the adjacent. So we're working with adjacent and hypotenuse. We're going to use cos. So we're trying to find theta. We're using cos, so we write cos theta. And that equals the adjacent over the hypotenuse. So 15 on 23. Now, because we're finding the angle, rather than just press cos, we'll need to get rid of that cos by pressing the inverse cos. So that might be one button on your calculator, or you might need to press shift cos. In any case, we get that theta is 49.2942, and that's degrees. But we now need to round off, correct to the nearest degree. So 49.2, etc. rounded off to the nearest whole number. Simply, theta would equal 49 degrees there. Question 2, find the value of theta, this time correct to the nearest minute. Okay, some old hags can't always hide their old age. Identify the two sides. Well, there's our angle. So opposite, and that one, the adjacent. So we're going to be using tan. So we're trying to find theta. We write tan theta equals opposite over adjacent, so 7.2 over the 9.8. And again, we're trying to find theta, so we need to press the inverse tan. So again, it might be the shift tan on your calculator. So when we do that, 36.3044, now correct to the nearest minute. Now we round that off to the nearest minute. We use the degrees, minutes, seconds button, okay, which looks like that. And then we get 36 degrees 18 minutes, and it's rounded off to the nearest minute. Now just before we finish off, I'll explain a little bit about this degrees, minutes, seconds. If we have that on the calculator, that's what it looks like. Then if we press this button, okay, we want it to the nearest minute, pressing that button, or it might be shift that button, depending on your calculator. You want to test it out. What happens then, it changes. That's what the calculator now looks like. And that's degrees, and that's minutes, and that's seconds, okay, degrees, minutes, seconds. So we wanted to round off to the nearest minute. That's 36 degrees 18 minutes so far. We still look at the next bit, the seconds. And the cutoff point is 30. If it's less than 30, which it is, we leave it alone. If it was more than 30, we'd bump it up to 36.19. But given that it's less than 30, we're going to leave it as 36 degrees, 18 minutes.